Setting up this electronic control unit for the powder coating oven. This is a solid state relay. You get a switching voltage coming from the PID unit. This is the PID unit. It gets a switching voltage coming from it that triggers the solid state relay, and then you can run your output voltage from here. This is what will control the heating elements. But it gets pretty hot, I guess. So this one came with a heat sink for it, but it didn't come with any screws to mount the SSR to the heat sink. So I had to go down and get screws, and of course they're metric, so nothing that I had here would fit. So the first thing you've got to do is mount this relay. Well, it's not necessarily the first thing you got to do, but it's the first thing I'm going to do, is mount this relay to the heat sink. Now this heat sink is aluminum. It looks like it's cast or maybe drawn, I don't know, probably drawn. It has all aluminum. It's going to have some oxidation on it, so I'm just going to buff it up a little bit, kind of take some of the oxidation off of it to brighten it up a little bit. And the bottom of this solid state relay, I would imagine, is stainless steel. It's pretty bright, but I'm going to buff it up a little bit anyway. It doesn't want to buff. I'm going to take a rag with a little bit of lacquer thinner off on it, wipe those off real good. See, it's got a little, that's oxidation, dirt and oil and stuff like that coming off of that. Now, the reason I use lacquer thinner, ordinarily I use paint thinner because it's cheaper and it works just as good for oils and stuff as lacquer thinner does, but lacquer thinner evaporates faster. Paint thinner takes a while for it to evaporate. You could use alcohol for that, or just about any solvent. It takes the oils and stuff off and just cleans both those surfaces up. That's probably not necessary, but it makes for a better electrical connection, and a better electrical connection is pretty close to the same thing as a heat transfer connection. You give those a second to flash off. Now I've got some heat sink, silicone heat sink dielectric compound, and that's to help make a thermal bridge between these parts more efficient. I've had this, I got it a few years ago for working on some other project, and I don't remember what that was now. Luckily I had it. I doubt if there's any place in town you could buy it now. Radio Shack went out of business, and the store here that had the Radio Shack hadn't really been doing anything with it for years anyway. Nobody knew anything about any of that stuff. Smear that stuff around to make a good uniform connection. That's pretty good. It's simple as that. Just put the screws back in it, tighten them down, and once we get the electrical hooked up on that, it'll be good to go. This is the way it's going to be. It wouldn't be a bad idea if you have this in a contained space, a box, to have a fan on it to blow air, to make sure it gets plenty of air circulating on it to keep it cool. I guess that relay gets pretty hot. I either mount that to a solid metal surface that will help dissipate some of the heat from the heat sink, or get a fan and put in there. There's a solid state relay mounted up onto a heat sink. Now the heat sink has got grooves in it for screws to mount someplace. We'll figure that out later. Like I said, I never know what the hell I'm doing until I'm done. Hey, I got a test set up here, just jury rigged up to test this PID controller. I've got these just plug-in cables for some light fixtures that I had for some heat lamps. They're ceramic fixtures that I got that I wound up using in some of my equipment to put ceramic light bulbs in for heating up, and the fixtures are pretty nice, but I daisy chained them and hooked them up differently. So I had these wiring harnesses, or these plug-ins, left over, and they've got like a 16 or 20 gauge cable on them, which is plenty for what I'm doing here, and it's plenty to supply the power to this PID controller. And so I've got it set up, hooked up to 120, and I run some wire, and this happened to be 14 gauge wire, and it just happened to be what I had on the shelf. Then I got the same thing, another one of these cables. I run one leg of it to the output of the solid state relay, and then I run the 14 gauge wires over to a light fixture, and I've just got a little appliance bulb in there. That bulb will go in the powder coat oven as a light fixture in there once I get it all set up. But this is just trying out everything to see how it works. You can see there's a light glowing on the solid state relay showing it's activated, and the PID controller must be preset at 150 degrees, and there's a thermocouple there. There's two wires on the thermocouple, and I just assumed that the red one was positive and the blue one was negative, so I hooked that up to the positive and negative terminal. And I think it's preset for probably Celsius. Try to get this set up here statically like this before I hook it up. Let's see what happens if I put this thermocouple over here on the light bulb. Anyway, let's see what we can do about changing some of the stuff on that. Probably not going to get that thing to go to 150 degrees. I mean, I could, but I don't want to sit there long and deal with it. So I'll try to block some of that light. It's just kind of blinding me. Got spots in my eyes now, I can't see anything. I reset the target voltage down, or target temperature down to 50 degrees. I don't know why it's cycling on and off now. It shows 46 degrees, and it come on and then it goes off. Well, it's holding at 46 degrees right now. So I'm trying to decipher this thing. I've got to learn the language first, then we'll get it figured out. Anyway, I keep working on it till I get it figured out here. Okay, well, I wasted a lot of time trying to figure out how to set this thing up. I got it figured out how to set the temperature, and I did drop it down to 50 degrees. It seems like it might be working. I don't know, it was running up and down quite a bit lower than what the set temperature was, but we'll get that figured out. But I was looking at a way to change this over from Celsius to Fahrenheit, and I finally found instructions online that told me how to get in there to change it. And when I did get in and find that menu, I couldn't change it. So obviously this unit, the cheap unit, it can't be changed to read in Fahrenheit instead of Celsius. That's not a big deal. I can either order another one, a more expensive one, when I see how this one works, or just set it. I just want to be set to 450 degrees Celsius or Fahrenheit anyway, and that's, I think, 220 degrees Fahrenheit, something like, or Celsius, I think. 450 Fahrenheit, 220 Celsius, something like that. So we can set it Celsius. Powder coat doesn't know the difference. As far as I've seen, temperature variances don't seem to make too much difference on the powder coat anyway. I've seen it 25 to 50 degrees difference on the temperature, and I got it too hot one time. The new oven that I got wasn't set right. Temperature controller is not set to the same as what the temperature is. It's 100 degrees high, and that did kind of burn the stuff. We'll see how this works. It should be okay. I'll get things set up here. Like I said, I was just going to jury rig it. As far as hooking the PID controller up and the solid state relay up, that's fine. I just have to run power to the solid state relay and then hook it up to my burners in the oven. So we'll figure out how to go about doing that. For now, I'm going to go ahead and leave the PID unit hooked up to the 110 like it is right now, and I'm just going to run the 220 to the burners through the solid state relay. Once I get everything set up the way I want it, or have time to work on it, I'll build a box where I can just run one plug into it, just run one leg over to the PID unit and to a light switch for the lights inside. But for now, I'm just going to hook it up so I can see if it works and get it working. Obviously, I changed something on it because now it's up to 50 degrees on that. So I've got to figure out some way to mount that thermocouple in there. I think I've still got to change some of the parameters in this thing to make it work right. I don't understand all of the language they use in this yet. I figured out how to set up the parameters in the other little temperature controller I had, and how to adjust the temperature differential between when it kicked on and kicked off and stuff like that. But I haven't got this one all figured out yet. But getting it hooked up is a major thing, and I can set the temperature on it. See if we can't get it hooked up. Trying to come up with an idea of putting this thermocouple in. It's obviously meant to thread into something. Getting enough protrusion out of it to get a good temperature pickup on it was the idea, going through that thick cement board. I was just going to drill a hole in the cement board and stick this in there and dummy it up with some high temp RTV. But once I got to measuring it, OD on that, the threads was about 1/4 inch. So I took a 1/4 inch tap on there, and it looked like the threads matched up on it. So I went ahead and cut out this piece of aluminum, 60 thousandths thick, and I've got it drilled for sheet metal screws. And then I threaded that with a 1/4 20 tap and threaded this in there. And it kind of went, didn't really match exactly, I guess, I don't know. But anyway, the cover over that, the threaded portion, just kind of twisted off and just kind of started coming apart. You can see here it's all coming apart, but it's stuck in there, and it's stuck in there good enough to do what we need to do. That probe's going to stick out there into the oven quite a bit, so I'm going to go ahead and drill a hole through the cement board and feed this cable through there, and I might put a little bit of high temp RTV on there just to keep that more solid back here and hold that probe out there. But anyway, looks like it's going to work. I'll put some sheet metal screws through there into the cement board. That seems to hold pretty good. So there's the mount for the thermocouple.